Okay, now comes, if you like, the non-calculus part of the problem. Remember, the non-calculus part of the problem is always the messier part of the problem. So we want to figure out this formula. This formula, the answer over here, which maybe I'll put in a box now, has this expressed much more simply, only in terms of x. And what we have to do now is to solve for dy dx using algebra and then solve in all the way in terms of x. So first of all, we solve for dy dx. So I do that by dividing the factor on the left-hand side. So I get here m x to the m minus 1 divided by n y to the n minus 1. And now I'm going to plug in. So I'll write this as m over n. This is x to the m minus 1. And now over here, I'm going to put in for y x to the m over n times n minus 1. All right? So now we're almost done. But unfortunately, we have this mess of exponents that we have to work out. I'm going to write it one more time. So I already recognize the factor a out front. That's not going to be a problem for me, and that's what I'm aiming for here. But now I have to encode all of these powers, so let's just write it out. It's m minus 1, and then it's minus the quantity n minus 1 times m over n. All right, so that's the law of exponents applied to this ratio here. And then we'll do the arithmetic maybe just over here in the next board. So we have here m minus 1 minus n minus 1 m over n is equal to m minus 1. And if I multiply n by this, I get minus m. And if the second factor is a minus, that's a plus. And so it's plus m over n. So altogether, the two m's cancel. And I have here minus 1 plus m over n. And lo and behold, that's the same thing as a minus 1, just what we wanted. All right, so this equals a x to the a minus 1. Again, just a bunch of arithmetic. From this point forward, from this substitution on, it's just the arithmetic of exponents.